In each of the figures that are labeled below, labeled figure 1 and figure 2, a force F is being applied to mass of m. In figure 1, the force is pushing down at an angle of theta, clearly visible. And in figure 2, it is pulling up at an angle of theta. Again, it's very much understandable. There is a friction force between the mass and the surface in both the figures, and assuming that the mass has the same constant acceleration in the horizontal direction, but none in the vertical direction in each figure. So in which figure is the force of kinetic friction the greatest? Explain your answer. Okay, so the friction force will definitely be in the backside direction. So that's back, that's back. The acceleration is same, so that's A, that's A. The normal reaction in this case, let's say, is Fn1. In this case, let's say, is Fn2. The weight force is, of course, mg in both the cases. And here, if we make the components of F along the motion, so that's going to be F cosine of theta, and perpendicular to the motion, that's going to be F sine of theta. So that's going to be here, which is F sine of theta. Likewise, over here, the horizontal components, and this is theta, so this is also theta as per the alternate angles. So this is going to be F cosine of theta, and this is going to be F sine of theta. All right. Now, if you write the equations of the Newton's as per Newton's law, then if you write the equations of the vertical force. So since vertically there is no acceleration, so net force should be zero, right? So upward force, which is Fn1, should be equal to the downward force, which is F sine theta plus mg. Okay. We need to find what, then in which of the figure the force of kinetic friction is greatest. All right. Uh, And the other equation which we get is the horizontal one. So F cos theta, which is the horizontal force towards the right, minus the friction force F1, that is equal to ma, right? Ma. And the acceleration is same in both the cases. All right. So if we rearrange, then F1 is going to be, this is equation number 1, this is equation number 2. So F1 is going to be F cosine of theta minus ma. Okay, that's what we got from equation 1. Equation 2 seems like equation 1 does not really have any relevance. And that's what I'm going to do with the other figure as well. So again, the horizontal force is going to be F cosine of theta minus the friction force as F1, that is equal to ma. It's not F1 actually, that has to be F2. So let me just change it to F2. F2 is equal to ma. So if I rearrange, then friction force F2 is going to be F cosine of theta minus ma. F cosine of theta minus ma. So in this case, since the angle is also same, the force is also same. So as per the equation which we are getting, the friction force turns out to be the very same. Turns out to be the very same. In which figure the force of kinetic friction is greatest, it is actually the very same in both the cases, and we can clearly see it's F cos theta minus ma. That's got to be the force of friction. So from this calculation, we can definitely comment that it is same in both the cases. Thank you.